All right, guys, this is the second video. Last time we were talking about evolution, evidence for evolution, and now we're talking about the opposite theory. Really, the only opposing theory is design. So if you guys see these pictures, we'll be talking about different ways that scientists look at the natural world and sometimes conclude design. The real question is, should we look at the biological world, things with DNA, living organisms, and conclude design? And I'm going to argue that Charles Darwin, in his book, a really famous book published in 1858, The Origin of the Species, was constantly comparing these two theories between evolution and design, the opposite theory. So last time I basically wore this hat, evolution, and you can feel free to pause the video and review these lines of evidence, A through F, and kind of summarize what those evidences were for. But today, my outline here is talking about design itself. So here's a brief outline of some of the evidence for design. We'll look at 5 different lines of evidence argument. I want to start by asking, kind of debunking objections. Last time I said that just disagreeing that evolution is a theory. You say evolution is a theory, so we shouldn't teach it because it's just a theory. I think it's a horrible reason to disagree with evolution. I also think that a horrible reason to disagree with design is this one. The majority of scientists believe that evolution is the best account of all life on Earth. I think that the majority never determines truth. John Scopes, one of the first court trials testing the teaching of evolution in Tennessee. First guy who wanted to teach it, John Scopes. They used him as a kind of a test trial in Dayton, Tennessee. Said education, means broadening, advancing, and if you limit a teacher to only one side of anything, the whole country will eventually have only one thought, be one individual. I believe in teaching every aspect of every problem or theory. And so just because at the time in Tennessee, lots of people objected to the teaching of evolution, didn't make evolution false, is the same thing today. Just because a lot of scientists believe that macroevolution explains all of life on Earth doesn't make it true. Quote by Bryant McGill says, the supreme lesson of education is to think for yourself. Absent this attainment, education creates dangerous, stupefying conformity. I need to tell you guys about an opposing theory for this not to just be brainwashing. If I just ended of the evolution unit on the evidence for evolution and didn't present any of its weaknesses or any of the evidence against, then that would just be brainwashing. So that's what we're talking about today. I'm wearing my design hat today. Same line of reasoning. There's a dissent claim. It says, we are skeptical of claims for the ability of random mutation and natural selection to account for the complexity of life. Careful examination of the evidence for Darwinian theory should be encouraged. And this statement is signed by over 300 prominent scientists, some educated at MIT, some at Cambridge, from microbiologists to philosophers of science to ethicists and philosophers and biologists. So, and paleontologists, the gamut. So that there are people who disagree. There are scientists who disagree that macroevolution explains everything. It doesn't make either one right. Okay, last thing, quote by J.Y. Chen, famous paleontologist in China, says that in China we can criticize Darwin, but not the government. In America you can criticize the government, but not Darwin. One of my favorite quotes, just saying that we should be skeptical, and you should in science be allowed to challenge scientific thinkers and theories. It's just so political, evolution is so political that it's difficult to challenge Darwin's theory, but lots of scientists are doing it at an increasing rate. So I'm going to open up with a question. Is there a conflict between evolution and design? Is there a conflict between this theory that life is designed and that life has evolved? And my first thing I want to say, no, there isn't a conflict between design and evolution if you're talking about microevolution, because evolution obviously happens. We've talked about 4 definitions of the word evolution. Change happens over time. Change happens in a gene pool. The number of redheads will change over the next 100 years. The percent of redheads in our population will change. So those things, finch beaks change within a matter of years. 2 years after that drought in 1977. Those things happen. They're inevitable. So there is no conflict between design and microevolution. But what there is an apparent conflict between is macroevolution, that DNA can evolve from chemicals and that all of life can have evolved from those basic building blocks of a cell like DNA. So can natural selection and mutation explain every single life form on planet Earth? And that's the question we're talking about today. That's the real disagreement between design and macroevolution. Okay, so let's jump in. First argument, guys, number 1. So if you're taking notes on the table, this would be the first argument. is that design is a scientific conclusion. So paleontologists are probably the first example that come to mind for me. They dig into the ground and they'll find rocks, they'll find bones, they'll find man-made things like chariots. So this is a chariot you see here. And when you see this chariot, the paleontologist will stop and see the complexity of this design thing, see the arrangement of this metal that couldn't have come about by a random process. So if it's not the result of a random natural process, then the conclusion is design. And so they dig into the ground, they see this chariot, and they conclude design. They dig into the ground, they see pots that are formed like this, and their conclusion is design. And they use that every day in their field of science. So again, if you look at these things that happen, the formation of dunes, spiral galaxies, the Grand Canyon, I can look at a natural process, even these spirals, simple patterns, and conclude that a natural process has caused this thing to occur. And I can conclude evolution, I can conclude different scientific conclusions. But if I look at a cell phone, or if I look at computer code, or I look at Romeo and Juliet, I see the kind of complexity that I will conclude design, just like the paleontologist concluded design if we saw a chariot. So if you see this list and you conclude design, intelligent design, or you conclude a random process over time, so basically random versus non-random, something that it can be simple, something that is too complex to come about randomly. I see that computer code, I would pause the video and try and place these things. Computer code is definitely designed, a watch would surely be designed, a riverbed, if it's not man-made, if they're, that what we normally see, what we typically see is it's a random process over time like erosion. A cup is more gray, right? You can have like a cup-shaped rock that a rock you could use as a cup functionally, but if you see that that big jar, that innately ornamented jar, I would conclude design. So it depends on the kind of cup, I guess. A rock could be random. A spiral pattern, simple patterns, even like spirals that you see, can be random. An iron chariot would be designed. So I think the first argument is that, guys, is that design is a scientific conclusion. It can be a scientific conclusion, and that's the first step in understanding this argument for design. Okay. So argument number two, if you guys are taking notes, this is the next row down. Evidence number two is that DNA itself is designed. If you look at a DNA molecule, and if you can imagine with me a world before there was DNA, before there was any life at all, if you can imagine over 3 billion years ago, current scientists would estimate, before there was DNA in any way, you have to take basic chemical building blocks like hydrogen, carbon, nitrogen, phosphorus, oxygen, all those, the nitrogen bases that we've talked about this year, A, C, T, and G of DNA. You have to assemble those chemical pieces, those molecules, into a functional DNA molecule or functional RNA molecule. And what they've found is that for a DNA molecule to randomly assemble from parts, the chances of it, if you had to roll a dice on it, the chances of it are incredibly rare. It's 1 × 10⁻⁵. And to give some perspective on this, if you had to take a trillion, if you had to roll the dice 1 trillion times, it would happen once. That would be 1 × 10⁻12. 1 × 10⁻13 would be 10 times as hard. So every time you add an exponent here, it's 10 times more difficult. That's how the exponent works. So 1 × 10⁻25 is so incredibly rare that a lot of mathematicians will say that anything really over 1 × 10⁻20 or 23rd will happen so infrequently that it won't happen by chance in the history of our universe. You shouldn't go about looking for things to happen by chance if it's beyond a certain scope. So let's say it's 1 × 10⁻23rd. DNA won't form randomly. So what scientists then say is, if you guys can see this picture with me, what we've done earlier this year is that DNA going from a parent strand to 2 daughter strands needs proteins. It needs a protein here called helicase to cut. It needs proteins called DNA polymerase to do the gluing and the spell checking. And with those proteins, DNA can assemble. So this impossible task of 1 × 10⁻25, assembling one DNA molecule, can actually be explained if you have the protein molecules. So maybe that's how you counter this objection. But the problem is, for the protein also needs to self-assemble. And because there are more letters, more amino acids to form a protein, it is more difficult to get one functional protein than it is to get a functional DNA molecule. So to form protein from random parts randomly over time is actually harder to explain than it is to form a DNA molecule over time. And so this is even more impossible. Like, this is well beyond the scope. And this is the work of Douglas Axe at MIT. Undeniable. He's done a lot of work with proteins to get this number. They estimate it lower several decades ago, but now they think it's about this. And his work doesn't seem to be disproven. So his work is important. That this is impossible to happen by a random process. And again, to go back a couple slides, if it's not happening by a random process over time, if we can't count on it, it seems so improbable that we would use the word impossible mathematically that my only other conclusion is that DNA was designed, protein was designed. Before the work of all these scientists we've talked about this year in discovering DNA, before the 1950s, 100 years before, Darwin really knew nothing about how DNA was structured. He'd even look at a cell in a microscope and just see, they called it, Hooke called it a cell just because it looked like a little blob, looked like a little monk's cell. Darwin knew nothing about the complexity of the cell, knew nothing about the complexity of DNA. So when he proposed his theory of macroevolution, there was a lot of missing information. And it seems now that we know so much about DNA and so much about protein, we can conclude those things were designed. So that's the argument. Russian scientist Theodosius Dobzhansky says natural selection is sometimes described as a mechanism capable of realizing the highest degree of improbability. So maybe it seems impossible, but natural selection might work on it. So maybe that's how it's possible. He says, what I would like to plead with you that simply, please realize you cannot use the words natural selection loosely. Pre-biological natural selection is a contradiction in terms. You need something that can reproduce for natural selection to work. You can't have something reproducing itself until you have a functional DNA molecule. So natural selection can't work on it. Natural selection doesn't help explain it either. Stephen Meyer says that natural selection presupposes, it assumes the existence of this DNA in these proteins. But to explain those, we need something like design to explain it, at least so far from the evidence. Antony Flew, famous atheist from Oxford, late 20th century, when he was older, concluded that from the complexity of biology, it seems like you need some kind of intelligent source for the complexity of biology, especially in the machines we see in the cell, especially in DNA. So there's lots of conclusions based on the evidence. It was the evidence itself that led me to this conclusion. So it doesn't seem like it seems like this can be a scientific conclusion. Okay, evidence number 3. Guys, I'm gonna go a little faster now. Is evolution always beneficial? Can mutations be beneficial? Are they always beneficial? Michael Behe, a guy who wrote Darwin's Black Box, this book, Darwin's Black Box, great book. I would encourage you to pick it up and read it. Would argue he's done an article in Cell magazine a couple years ago, 2013, where he looked at all of the research concerning bacteria. The only kind of species that we can really test macroevolution are the kinds of species that reproduce so quickly that we can test mutations. It's really hard to test it in humans. That would take millions of years for macroevolution to really be seen. But with bacteria that can have trillions of generations in a matter of years, we can test macroevolution. So let's test it. So Michael Behe looked at all the research done in the last 50 years, sorry, the last 40 years. And in those 40 years, in those trillions of generations of bacteria, he only saw 2 examples of positive mutations of where bacteria actually gain function through mutations. 100 to 1,000 times more likely, mutations will cause the bacteria to lose function or modify their existing function. So is it likely for mutations to explain all of the features we see in the natural world? And in the species that we can test in the laboratory, bacteria, it seems so uncommon for that species to ever gain a function that it seems unlikely that mutations can explain it. This was his paper, again, published in this is the Quarterly Review of Biology. So go read that if you're interested. So the real question is, a student drew this for me a couple years ago. If it's hard to see, let me describe it to you. There's a bunch of little sandbags called microevolution pouring into this big vat called macroevolution. And he says, oh, all that macroevolution really is a bunch of microevolution adding up together and pouring into this big vat. And so millions of years later, you eventually get to macroevolution. And the one thing I would disagree with that I would say, no, I think this is a bad analogy, is the difference between micro and macro, as we did that Venn diagram. One of the biggest differences is that microevolution can happen, genetic change can happen without mutations needing to explain it. But macroevolution does require unique gain of function from random mutation, and that's macro. So can mutations explain this big vat, this jump from this top bucket micro to this big vat macro. And it seems like the one species that we can test, bacteria, it doesn't seem likely that mutations can explain all those new functions. So it seems like we need an intelligence to design. We have lots of examples of us designing computer code and cell phones. Intelligence designs all the time, but mutations do not, from all of the evidence that we have. So mutations cannot explain all of these new gains of function. David Berlinski, little video, if you want to type this into your computer. I don't like the name of this video, but the talk itself is really good. He talks through how mutations are unable to explain all of the variety that we see in the laboratory. And if we can't prove it with some kind of evidence in a laboratory, if we can't actually test it, even on species like bacteria, then we can't conclude that this is scientific. David Berlinski is an atheist. He's taught at Stanford. He was educated at Princeton. Okay, evidence number 4, guys. Again, I'm rolling. This is a period of time. You can imagine going back in time, not 10,000 years ago or 30,000 years ago or 100,000 years ago, not a million years ago, not 100 million years ago, but about 540 to 500 million years ago. You find this period of time in the fossil record called the Cambrian explosion. Before this period of time, there was only about 3 different types of body plans in the world that we saw. And after this period of time, there was about 23 different body plans. The grand majority of the body plans we still have today sprang up out of nowhere. It's almost like life had this big bang. It's called evolution's big bang, this Cambrian explosion. Can this be explained by the slow mutational change through natural selection that we see in Darwin's theory? So in this time, we see things come up like trilobites, these big, huge crab-like trilobites that would roam the oceans. They kind of dominated the world this time. Hallucigenia sparsa. It's almost like you're having a hallucination. So they call it hallucigenia sparsa. This guy's so weird looking. This guy looks like an anomaly. He's Anomalocaris. All of these guys came up during the Cambrian explosion. You get new features like eyes, legs, heads, tails, tentacles, pinchers, mouths, and guts that were not there before. Stephen Meyer is an author I would go to and read if you're interested in this. His book Darwin's Doubt covers this in depth. So these features come up where they were not there before. So this has to be the result of mutations happening to produce these traits. They've since found that the Cambrian explosion really happened in a limited period of time, like 15 to 20 million years, where the majority of those changes took place. You need a huge amount of new information. If genes produce proteins, if DNA produces RNA produces protein, then you need new genetic information to produce these new traits that require proteins. So where does this new influx of genetic information come from? It seems like there was only a few body plan types, a few phyla. Phyla is the word that's used to describe body plan type. Giraffes, rats, wolves, and humans all have the same basic phyla, are in the same phyla. We all have the same basic body plan. We have an abdomen. We have 2 arms and 2 legs. We have a neck and a head and 2 eyes. We're all part of the same phyla. So for different phyla, 20 different phyla to pop up, you would expect that to take longer than changes within a phyla. So you would expect this to take hundreds of millions of years, if not billions of years, for this many phyla to arise out of natural selection. And you see this happen within a period of 15 million years. This cannot be explained by this gradual change that evolution requires. So evolution can't explain the Cambrian explosion. The Cambrian life that we see must have been designed. And so that's the argument. Darwin himself admitted that the Cambrian system presents a valid argument against his view of evolution. So he says, at the time, he said, okay, there's not a lot of evidence for the Cambrian explosion evolving slowly. We'll need more evidence. And since then, the paleontology that we found, this guy, J.Y. Chen, is the main paleontologist in China and the main dig in China that has uncovered the most number of Cambrian fossils we've ever had in the world. And he's the one who's questioning how Darwin proposed the theory of evolution. He says, I need to question Darwin the way he came up with it because of the evidence I'm finding in the Cambrian period. So Cambrian life was designed, it didn't evolve. That might be, or we don't know, but we can't conclude evolution given that evidence. Okay, last piece of evidence, guys, is this thing called irreducible complexity. If you find a really complex system, like the blood clotting in your body, or you might argue like ATP synthase in a mitochondria, or the bacterial flagellum, this bacterial tail, this 50 gene, this bacterial tail is one of the most efficient machines in the history of the universe. I should say that The one video I want you to watch here is this video. Type this in, Unlocking the Mystery of Life, Irreducible Complexity clip. This is a great 4.5-minute clip that talks about a Harvard biologist saying the bacterial flagellum is the most efficient motor we've ever witnessed. It can cause a bacteria to stop on a dime and turn the other direction. It uses energy more efficiently than any engine we've ever designed. So this tail requires 50 different genes. There's a crankshaft, there's a motor, there's C rings and L rings and P rings. There's different things, just like you would design an engine, is the kind of complexity you find in a bacterial tail. If you have a mutation to one of these 50 different genes, then the whole tail doesn't work, or it's slightly modified. And so if you can't explain how something this complex could evolve slowly, step by step by step by step, then it seems like we can conclude design. Similarly, in blood clotting, if you guys see this, I'm going to zoom in real quick. In blood clotting, there's a 16-step chain in our bodies, how when you scrape your elbow, you need to be able to clot that from the inside. The blood itself needs to create this coagulation event, this blood clotting. And there's a 16-step chain. We don't find in mammals anything really any simpler than that. So if you have to explain how blood clotting, before there was blood clotting at all, you have to explain how blood clotting came about slowly by mutation by mutation by mutation by mutation. You have to explain how this could have been useful to an organism step by step by step. But if we only find in nature that it's only useful 16 steps at once, those 16 things came together all at once, it seems like that needs to be designed. It's too complex to have evolved slowly step by step by step. Similarly, this is the best analogy I have. This might help make sense of this for you. Is that if you have a mouse trap, you have these 5 parts to a mouse trap, can you imagine removing one of the parts and having it still be useful? If I try and remove the hammer, if I try and remove the catch, if I try and remove the spring, if I try and remove the holding bar, the whole thing doesn't work and it's not useful. It needs to, all 5 pieces need to be put there at one time. We designed this mouse trap for a function. We put those parts there all at the same time we designed it. It seems like we have the same kind of thing going on in a bacterial tail and blood clotting and lots of other pieces, those two that we find in nature. But blood clotting and bacterial flagellum might be the 2 clearest examples that is impossible to explain by design. So do we conclude, when we look at the complex machines we see in the cell, do we conclude it evolved slowly, or do we conclude design? I'm arguing design. You can pause this and read this quote. Darwin himself said, if it could be demonstrated that any complex organ existed which could not possibly have been formed by numerous successive slight modifications, my theory would absolutely break down. So he's saying you need to explain things by slight, step by step by step mutations to explain his theory. And if you find a complex system like a bacterial flagellum or blood clotting and lots of other examples, then evolution will break down and we have to conclude design. So that's it. Feel free to pause this and review those 5 lines of evidence for design. Thanks, guys.